students, welcome to my another session, quantum numbers. This is also very important question for 8 marks. So, how to write this question, how to represent this question, I am going to explain. Okay, the question will be given like this. How are quantum numbers N, L, M are arrayed, and explain the significance of quantum numbers. Okay, so they may ask the questions in various ways, but you have to write the same answer, what I am going to explain. First one, to describe the position of electron in an atom, the quantum numbers has been discovered, are introduced. Okay, first of all, what is the first point here? To describe the position of an electron in an atom. The four quantum numbers required. The four quantum numbers has been introduced. Okay, some books they have given to describe the shapes of orbit, to describe the energy of electron, or to describe the shapes of orbitals. The four quantum numbers required. This is also point. If you want, you can write. So, but where the exact electron is present was explained by four quantum numbers. Okay, this is first point. The second point, the question given here, how quantum numbers N, L, M are obtained. So these three quantum numbers. Second point, the quantum numbers N, L, and M are obtained from Schrodinger wave equation. Schrodinger wave equation. From Schrodinger wave equation, we got the three quantum numbers. Okay. First of all, what are the four quantum numbers? We can write this as a shortcut form, PAMS. PAMS. P represent the principal quantum number. A represent the azimuthal quantum number. M represent the magnetic quantum number. S represent the spin quantum number. So first of all, you have to write one by one what are the quantum numbers. First, quantum numbers are four types. Quantum numbers are four types. First one is principal quantum number. Principal quantum number, right? Second one, azimuthal quantum number, right? This we can take it as n. This we can take it as small n. Third one, magnetic quantum number, right? Small n. Fourth one, spin quantum number. Spin quantum number. This you can take small n. Remember, all letters you have to represent in small letters only. Okay, you have to represent in small letters only. First of all, put the side heading principal quantum number. What do you mean by principal quantum number? First of all, put the side heading like this. First of all, you have to write the scientist name. Who discovered this one? Okay, so it was proposed by Niels Bohr. Okay, underline this Niels Bohr, right? The second one is denoted by letter small n. Okay, so third one, what is the n value? So n value will be given 1, 2, 3, 4, and so on. Okay. Next, fourth one. The maximum number of electrons. The maximum number of electrons in an energy level is equal to 2n square. This is very important, 2n square. So we can take n is equal, we can take it as n is equal shell, or you can take energy level. For example, if I take first shell, if you take the first shell n equals to 1, so 2 into the maximum number of electrons, how much? N equals to 1. So 2 into 1 equals to how many electrons? 2 electrons. In first shell we are having only 2 electrons, right? Like that. If you are having 2, n equals to 2. 2 into 2, how much? You will get, so 1 square, that means in 1 square. So if you are taking 2, if n equals to 2, so 2 square how much? 4 into 2, how much? 8. The second energy level will be 8. So the fifth point, that means you can take it as the significance. What is the significance here? It tells the shape and, or you can take the size, not shape. Size and energy of orbit. Size and energy of orbit. Next, n value increases. Size and energy of orbit also increases. This is about principal quantum number. Very, very important. You have to remember. Okay, only 5 points. First of all, for all quantum numbers, first of all, who has discovered that? Niels Bohr has discovered this. Next, what is the letter denoted by n? N value will be given 1, 2, 3, 4. A maximum number of electrons you can write 2n square. Next, what is the significance here? It mainly explains about the size and energy of a main energy level, or you can take it as orbit. The second quantum number is azimuthal. Quantum number, or you can also call it as azimuthal quantum number. You can also call it as quantum number. You can also call it as angular momentum. Quantum number, or you can take it as subsidiary quantum number. So all are same for azimuthal quantum number. So first point for common, it was discovered, or it was proposed by Sommerfeld. This is the first point. You have to underline Sommerfeld. Here also, letter denoted by n values. So you can also take it as Sommerfeld. Next, second point is it denoted by letter L, letter small l, right? Next, third one, L values depends on n value. Okay, so what is the L value here? L equals to n minus 1. This is very important. Okay, so that means if n equals to 1, you can take it as L equals to n minus 1. How much? 0. Right? That means L value you can take it as n equals to 1. So L value n equals to 1 minus 1. How much you will get? 0. Right? So like that, if n value is equal to 2, so L becomes 2, you will get 1. Like that. Next, fourth one, you can take it as significance. Significance. What is the significance here? It explains the, it explains the, it explain the, explain the shapes of orbitals. Shapes of orbitals. Or you can take it as sub-energy levels. You can take it as sub-energy levels. Sub-energy levels. It explains the shapes of sub-energy level and how much electrons are present in this. So we are going to learn about this. And okay. So first of all, you have to draw one table. You will get the answer very easily. Very quickly, I am going to write the table. First of all, you can take serial number, right? Now you can take n value. Okay. So direct I am taking n here. Directly you can take L value. Okay, L value in bracket you can write down n minus 1, right? Now, shape of orbital and last and final number of suborbitals. Okay, so number of suborbitals also we can learn. See, first of all, for this, no need to do this. Esther, so no need to take this. Directly you can take. Look at here. Serial number 1. N value. If n value is 1, n minus 1 value, how much become? 1 minus 1. It becomes 0. Right? Shape is orbitals. So shape. You can take orbital. Here. Orbital shape. You can take that. So S orbital. You can take S orbital. Okay. What is the shape here? Spherical. Spherical shape it is. Okay. Next, second one is if you take n value 2. So now coming to the 2 minus 1, how much it is? 1. So it is p orbital. What is the shape here? Dumbbell. Dumbbell. So or you can take it as the spelling. Some books they have given like this. Bell. Both are correct. So third one. So if n value equals to 3. So 3 minus 1, how much? 2. Right? So you can take d orbital. Orbital. What is the shape here? Double dumbbell. Double dumbbell. Next, fourth one. N value is 4. 4 minus 1. How much we will get? 3 F orbital. And it is 4-fold dumbbell. 4-fold dumbbell structure. Okay. 4-fold dumbbell structure. So you have to draw this table in the answer. Okay. Very important. Fourth table. Only you have to write this table. Now coming to the next one. Third one. That means, what is the significance of azimuthal quantum number? It explains the shapes of orbitals. How many sub-energy level? That means shapes of orbital as well as you will get the orbitals also here. Now coming to the next one is magnetic quantum number. Magnetic quantum number. Magnetic quantum number. చూడండి ఇక్కడ మనకి magnetic quantum number same. What is the first point? It was proposed by Landau. The scientist name was Landau. Next, second point. It is denoted by or it denoted by or you can write denoted by small m, the letter small m. So m value is depends on L value. Okay, what is the m value here? 2L plus 1. M value you can take it as 2L plus 1. This is the exception for s orbital. Coming to the p orbital, what is the significance? Significance. What is the significance here? It describe the describes the orientation orientation of electron in space. It explains the it describes the orientation of electron in space. The first one. Second one, it explains about the number of subshells present in an orbital. Number of subshells which are sub energy levels, or you can take it as suborbitals. Number of suborbitals present in this energy level. So now I am going to write here. So next one, number of next point. What is the next point? Number of subshells, or you can take that suborbitals. Orbitals present in an orbital. ఓకే ఆర్బిటాల్లో సబ్ ఆర్బిటల్స్ కూడా ఉంటాయి. ఎలా ఉంటాయో చెప్పారన్నమాట. దీనికి కూడా ఒక చిన్న టేబుల్ డ్రా చేయండి. సో గెట్ ఫస్ట్ వన్ ఈస్ సీరియల్ నంబర్. సో n వాల్యూ, నెక్స్ట్ l వాల్యూ, m వాల్యూ, ఆర్బిటాల్, సబ్ ఆర్బిటల్స్. ఓకే, ఇక్కడ చూడండి వెరీ ఇంపార్టెంట్. ఇక్కడ చూడండి సీరియల్ నెంబర్ 1 తీసుకున్నాం. మనం n వాల్యూ 1 తీసుకున్నాం అనుకోండి, n వాల్యూ ఆటోమేటిక్ గా 0 వస్తుంది. ఇఫ్ ఇట్ ఈస్ 0, m వాల్యూ ఆల్సో 0. ఈ ఆర్బిటల్ ఏమంటుందంటే s ఆర్బిటల్ అంటారు. s ఆర్బిటల్. s ఆర్బిటల్ ఏమైనా సబ్ ఎనర్జీ లెవెల్స్ ఉన్నాయా? నో, ఓన్లీ వన్. ఇట్ ఈస్ ఇన్ ద స్పెరికల్ ఫార్మ్. సెకండ్ వన్ వచ్చేసి n వాల్యూ 2 తీసుకున్నాము, l వాల్యూ 1 వస్తుంది. అంటే ఏంటంటే l వాల్యూ n minus 1. సో యూ కెన్ టేక్ n minus 1 directly. You can take n minus 1. So m value తీసుకున్నాము. m value starts from minus to 0 plus 1. Okay, minus to 0 plus, like that it will come. So ఇది ఒకటి వచ్చింది అనుకోండి, m value నేను ఆల్రెడీ చూపించాను 2l plus 1. సో ఇది ఎంత 2l plus 1. ఓకే, ఇప్పుడు 2 తీసుకున్నాం అనుకోండి, ఇక్కడ వాల్యూ వచ్చేసి 2, n వాల్యూ 2 ఉంది. ఇంటూ l వాల్యూ ఎంత ఉంది? 2 నే ఉంది, 1 ఉంది l వాల్యూ. ఓకే, ప్లస్ 1. చూడండి 2 into 1 ఎంత? 2 plus 1 ఎంత? 3. 3 we get. Okay, if l value 1, m value becomes 3. So it is represent the p orbital. So p orbital ఎన్ని సబ్షెల్స్ ఉన్నాయి? సబ్ ఆర్బిటల్స్ ఉన్నాయి. కంప్లీట్ గా 3 ఉన్నాయి. ఏంటి అవి? px, py and pz. మూడు రకాల సబ్ ఆర్బిటల్స్ ఉన్నాయి. నెక్స్ట్ థర్డ్ వన్, ఒకవేళ n వాల్యూ 3 అనుకోండి, l వాల్యూ ఆటోమేటిక్ గా 2 అవుతుంది. m వాల్యూ ఎంత అవుతుంది? ఇక్కడ చూడండి 2, ఇంతకుముందు 1 తీసుకున్నాక 2 తీసుకున్నాం. 2 into 2 ఎంత? 4. 4 plus 1 ఎంత? 5. సో వాల్యూ ఎంత? 5 వస్తుంది. సో మనకి ఎంత వస్తుంది p ఆర్బిటల్? ఇక్కడ ఏమొస్తుంది? d ఆర్బిటల్ వస్తుంది. సో ఎన్ని ఉన్నాయి కంప్లీట్ గా సబ్ ఆర్బిటల్స్? ఎన్ని ఉన్నాయి? నంబర్ ఆఫ్ సబ్ ఆర్బిటల్స్. ఓకే, ఇట్ రిప్రజెంట్ ద నంబర్ ఆఫ్ సబ్ ఆర్బిటల్స్. ఎన్ని వస్తాయి మనకు? p dxy, dyz, dzx, and dx square minus y square. This also we can take it as dx square y square also, and dz square. Next, ఒకవేళ 4 ఉంది అనుకోండి సీరియల్ నెంబర్, దీంట్లో n వాల్యూ మనం 4 తీసుకుంటే l వాల్యూ 3 వస్తుంది. సో మనకి ఇక్కడ 2 into 3 వస్తుంది. ఎంత? 6. 6 plus 1 ఎంత? 7 వస్తుంది. అది f ఆర్బిటల్ వస్తుంది. f ఆర్బిటల్ లో ఎన్ని సబ్ ఆర్బిటల్స్ ఉన్నాయి? సబ్ ఆర్బిటల్స్. So we already written in the here suborbitals. Total suborbitals how many? 7 suborbitals. This is about the magnetic quantum number. It explains about the orientation of electron in space as well as the number of suborbitals present in each orbital. Next, finally, we can take it as spin quantum number. Spin quantum number. Finally, spin quantum number తీసుకుంటే it denoted by First of all, it was proposed by Uhlenbeck, Uhlenbeck and Goldsmith. Okay, Uhlenbeck and Goldsmith. Next, second point. It denoted by smallest. The letter smallest. Third one. What is the value of smallest? It represents the rotation or spin of electron. Spin of electron on its own axis. Own axis. Spin of electron in its own axis. So what is the spin is exhibited by the electron? Generally, in an orbital, we can adjust two electrons, right? So one electron rotation is clockwise direction, another anti-clockwise. So if the electron rotation is like this represents the clockwise spin. So if the notation is like this we can represent the anti-clockwise spin. So in an orbital, సో ఒక ఆర్బిటాల్ లో తీసుకుంటే మనకు ఒక ఎలక్ట్రాన్ ఇలా ఉంటుంది, ఒక ఎలక్ట్రాన్ రొటేషన్ ఇలా ఉంటుంది. అంటే ఒక ఎలక్ట్రాన్ ఏమో ద ఓన్ స్పిన్ అంటుంది, ఎలక్ట్రాన్ ఓన్ స్పిన్ అంటాం. అంటే ఎలక్ట్రాన్ ఒకటేమో క్లాక్ వైజ్ డైరెక్షన్ లో రివాల్వ్ అయితే ఒకటేమో యాంటీ క్లాక్ వైజ్ లో రివాల్వ్ అవుతుంది అనమాట. దిస్ అబౌట్ quantum numbers. Very very important question. If you write like this, you will get 100% 8 marks. Thank you.